Alright, welcome back to my channel. In this video, we're going to go through the 2021 P5 Weighted Assessment 2 Science Practice paper from Eunice Primary School. Right, take note that I've changed the total score here because for my school, the P5 students are not learning certain topics this year in 2022. So I have removed those. So if you're my student this year, you understand further what I meant by that. Let's start with question 1. Now, a block of ice was placed in an empty plastic cup and left on a table to melt. The room temperature was 30 degrees Celsius. So you see a picture of a plastic cup. There's a big block of ice here, and there's some water. And the water, we can definitely infer that this water came from the ice that was melting, because it was empty at first. So where could the water have come from? It must have come from the melting ice, right? And you notice there's still a lot of ice, right? There's still ice inside. So when you see a mixture of ice, or the ice water and ice together, it tells you that melting is happening. It tells you melting is not over yet. I repeat, if you see ice plus water together, it means that melting is still happening. It's still ongoing. If that is the case, then it refers to this part of the graph. This part of the graph, you notice, this is a temperature versus time graph. So at the beginning, it's at 0 degrees Celsius. And this process here shows that whatever is happening here, all this part, whatever is happening here is a process called melting. And during melting, of course, the ice changes to state. You have your solid state here. Okay, but there will also be some ice water. But both of the solid ice and the ice water will still be at, you see, 0 degrees Celsius. At this point, you see this point that I'm pointing to here, this is a point whereby all ice has melted into water, meaning there's no more water left. So there's no more ice left. Okay, all the ice here has melted into water and there's no more ice left. When that happens, the temperature of the water, ice water, will start to rise as it gains heat from the environment until it reaches a temperature where it starts to level off. It's called level off. This temperature will be the room temperature, where whatever the room temperature is. It can be the air conditioned room, it can be your classroom temperature, which is higher temperature. Doesn't matter where it is, but it will be at the room temperature. And at this point, if you apply some heat to it, what will happen is that then the water starts to gain heat. Water starts to gain heat. What will happen? As water actually, so long as water is in an environment where the environment is at a higher temperature, there will always be something happening. This is called evaporation. Actually, evaporation happens all the way here. Evaporation happens at any temperature. So this is a process where the change in state is from a liquid to a gas. That's called evaporation. And at this point, notice here, where it levels off once again, notice 3 levels, 1, 2, 3. At this point in time here, what's happening when it reaches this temperature? It means that it has reached the process called boiling. Boiling is a specific temperature where a liquid changes to a gas. And the state here will all be in the gaseous state. Now bear this in mind because we will come back to this idea, these concepts here in the questions that follow in this worksheet. So coming back to this one now, melting ice, right? Ice water, so it's happening here. Ice is melting. So temperature is at 0 degrees Celsius, answer is 1. For those doing correction, please pause the video to take note of this annotation. And please draw out the graph. Let's move on. Question 2. Now, Jeanette just took a shower and her hair was still wet. Which of the following ways would help to dry her hair faster? Now, let's recap the factors that affect the rate of evaporation. So the factors that affect the rate of evaporation, we can remember them using this acronym WET. W stands for presence of wind. And then you have your E stands for the exposed surface area. What does T stands for? Temperature of the surroundings. So let's see which of these actions here are using a combination or any of these factors. So when Jenna is switch on the hair dryer and point it at her hair, hair dryer, for those who know, right, it will blow out wind, and the wind is at a higher temperature. So when using a hair dryer, you're trying to increase the rate of evaporation of the water on your wet hair by using a combination of wind and higher temperature, so effectively getting hot wind. So be careful when using a hair dryer. The hair dryer can be quite hot. If you are sitting in front of a fan, if Jeanette is sitting in front of a fan, she's just using wind, not increasing the temperature, not using anything like exposed surface area, using wind. If she's combing her hair to separate them, think of it like you are spreading your wet clothes out to dry. So when she combs her hair to separate them, she's increasing the exposed surface area. Okay, so that's using this. Now, putting a shower cap over a wet head will not help her hair to dry. Right, a shower, imagine this is her hair, her head, and this is her eyes, her smile here, her bangs. Then she put a shower cap over her head. How is the water supposed to evaporate? Even if it evaporates, it will just condense on the cooler surface and drip right back onto her hair, making it wet all over again. Then Jeanette will not be a happy girl, she will be a sad girl. Okay, so which of the following ways would help to dry her hair faster? A, B, and C will help her hair to dry faster. Let's go to question 3. Question 3, we will come back to this for those in my class in 2022, because we will be learning about electrical system in the next term, right? But not now, so we will skip this for now. For those in P6, if you are watching this as a revision, well, take note the answer is 2, but I will not be explaining this in this video because it's meant for my P5s. Similarly, my P5s, this is going to be tested at P6 instead. You will need to learn this next year, but not now. For those in P6, this is the answer. Now, question 5 is what we need to come to. So Denise placed a plant in a beaker of blue colored water. I highlighted blue. After 3 days, she cut the stem, and the diagram shows a cross section of the stem. So basically, we have to draw a diagram to show what happened. There is a plant inside. There's some blue colored water. This is the blue colored water here. And the stem was cut. We're not sure how much she cut, but she cut parts of it. Okay? And then the top part here is this part. All the tubes that we can see on top. Then she saw that parts of it turn blue, right? Part Y turned blue. Y is the part in the center. This part is the part in the center, turned blue. Okay, but part X did not. So if you remember from your lesson on your water carrying tube and food carrying tube, right? When you draw it this way, the pointy end here, the part that points inside, is always the water carrying tube. This one outside is like the big mouth. This is your food carrying tube. So if the tube turned blue, it means that the white tubes are the one carrying the water. If tube Y is the water carrying tube and that is transporting the water, it means the water carrying tubes are still there. It wasn't being cut. That's why the water carrying tube this is the water carrying tube. It still can transport all the way up. It wasn't cut. So the answer is number 2. Tube Y transports water from the roots below, roots, to all parts of the plant. It went up, 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 past the part that was cut and go up some more. Okay, now these are clear mistakes that you should spot and not choose. How can food be from the roots? Food is from leaves, because food are made in leaves. Water don't come from leaves. Water are absorbed through the roots. So these are two very clear mistakes that you shouldn't even think about choosing. Tube Y transport food from the leaves. This part here is correct. Food from the leaves is correct, right? Food comes from the leaves. But tube Y doesn't transport food because tube Y turns blue. And blue is the blue water, which means the blue water went up from below. If it goes up, it must be going through the water carrying tubes. So answer is 2. This one we will skip. This one is on photosynthesis. If you are a P6 student and you're watching this for your revision, take note the answer is 3. Okay. For my P5s, I still mark this for you because this can be linked to your P3 lesson on different organisms. What do plants need to make food to survive? Plants need light to make food. You learn this in primary 3. So when something is blocking the grass, then light that shines down, right, cannot shine on this part. Then this part of the grass directly beneath each of these stores will not be receiving light. Then the grass there will slowly die. They will wither, then they will die because they have no food, because they cannot make any food. And to make food, they need light. So answer here is number 3, yeah, my P5s. Next one, this question, the P5 can skip this. We will learn this next year. It's on photosynthesis. So if you're a P6 student watching this, take note that if light is shining on the leaves will be making food. And in the process of photosynthesis, water is required. If water is absorbed through the roots, then of course water will also be moving in down here to fill up the space that is left behind by the water that left it because it was absorbed by the roots up the water carrying tubes. So this spot will move over to X. Right, that's why the answer here is 2. It's about water is used for photosynthesis. Okay, now P5, back to you. Connor cut out a ring of the stem at part J and he wanted the plant daily. So there's a part that was cut, similar to what I drew earlier for you in the previous question. Now after a week, he observed the part of the stem above J. So this part is above J. This part is above J. This is the enlarged part of this diagram. The part above J became swollen like this, as shown. Why did it become swollen? Well, the bottom part wasn't swollen, right? What does it mean if the bottom part is not swollen? What is absorbed through the bottom part? Yes, you're right. Water. If it's not swollen, means the water could continue to pass through smoothly because the water carrying tubes were not cut. But the top part, the food carrying tube must have been cut. That's why the food was transferred down here. Then jam. No, cannot move forward anymore. So they keep on accumulating here. They keep on accumulating. Accumulate more and more, then start to swell up. Like your tummy after you ate a lot of food. So why did part X become swollen? It's because tubes carrying food were removed at J. And the food just kept on accumulating here until it swells. So this one I'll skip for my P5. It's on your energy conversion. This one, P5s, we'll get back to this in term 4 when we learn about electrical system. Okay, this one, P5, this is on your P4 topic. If you got this wrong, please go and take out your lower block cycles book to read it. Which of the following is true of a substance that has a melting point of 15 degrees Celsius and a boiling point of 140 degrees Celsius? Now, of course, clearly you can see the answer is 3. But what I need you to do now is to go through this lesson with me. I've drawn all the lines here for you on your worksheet. Now I'd like you to fill in the blanks. S for solid, L for liquid, G for gas. You may pause to copy this down. On the left hand side, you will see the characteristics of different states of matter. Has definite shape, has definite volume, can be compressed, cannot be compressed. So let's run through our understanding of the different states of matter. So does a solid have a definite shape? Yes. My pencil is a solid, the shape will stay like this today, tomorrow, the day after. Does this pencil, a solid, has a definite volume? Yes. It only occupies this amount of space, it will not occupy more space. Can it be compressed? No. This thing, I press it, it cannot be compressed. So here is no, cannot be compressed. Okay, so it cannot be compressed. How about liquid? Does a liquid have a definite shape? No. A liquid can take the shape of any container. I can pour water from this container to this container to this container. Right, it can take all kinds of shapes. So liquid has no definite shape. But the volume is definite. Definite means fixed. Fixed means it's not changing all the time. So if you go to a vending machine, it says a bottle of water at 500 ml water, and then go back tomorrow, you shouldn't see the amount of water decrease. It should still be the same. The volume is fixed. The liquid cannot be compressed, just like solid, right? So it cannot be compressed. The only state that matter can be compressed in is gas. It can be compressed. Gas has no definite shape because once you compress it, the shape will change, right? And gas has no definite volume because once you compress it, it occupies so much less space. So bear in mind this. Now let's come back to the question. So we want to talk about a substance that has a melting point at 15 degrees Celsius and boiling point of 140 degrees Celsius. Let's take a look. So this is my substance in a solid state. They say that at 15 degrees Celsius is a melting point, right? So if I heat it up to 10 degrees Celsius, yeah, it's still a solid. 11, yeah, it's still a solid. 12, yeah, still a solid. Haven't melted yet. 13, getting hot but still a solid. 14, still a solid. 15, ding ding ding, first important temperature, which this is called the melting point. This solid start to change into liquid. Then keep increasing temperature, 16, 17, 18, 19, 50, 70, 80, 100, 120, 130. Any temperature here is still a liquid. Until we reach the next important temperature, ding ding ding, this temperature here at 140 degrees Celsius is called the boiling point. At this point, the liquid definitely starts to boil and change into a gas. Now, of course, at this point, it can also change to a gas, but that process is called evaporation. It's not called boiling, because evaporation happens at any temperature. So now let's check which is true. It's a solid at 10 degrees Celsius. 10 degrees Celsius, solid, yes, correct. It's a liquid at 50 degrees Celsius. 50 is between 15 and 140. 50 is somewhere in between here. So correct. It's a liquid, right? Liquid. It has no definite shape at 70. So at 70, which is between these two, is a liquid state. So at 70 degrees Celsius, you're supposed to infer that it is in a liquid state. Liquid state, it has no definite shape. Let's check. Liquid state, definite shape. Yeah, no definite shape. True. Then next one, we talk about no definite volume. 120. 120 is below this. It is still a liquid. But liquid has a definite volume. So this is wrong. He's talking about a gas, but it hasn't become a gas yet. So this is wrong. So the answer is A, B, C. Right? So here's about condensation evaporation question. So what can be done to collect clean water? I need to copy this down, okay, children? So need to increase the rate of condensation. If there's more condensation here, wow, lots of condensation, then there'll be lots of water dripping into this container. But how can we have more condensation? We must have more water vapor condensing. Then there can be more condensation. How do we get more water vapor? Well, we must increase the rate of evaporation. Remember our WET to increase the rate of evaporation? If I'm using the same container, I cannot be changing the exposed surface area. There's no wind here. Alright, I can increase the heat, amount of heat. I put another Bunsen burner and another one. Increase the amount of heat, increasing the temperature here. That will cause the water to gain it faster, boil faster, evaporate faster, have more water vapor, condense faster, so I collect more water. So when I use so that's why adding another Bunsen burner is an idea. It increases temperature. Using a colder plate is good because when it's a cooler surface, this plate must always be a cooler surface. At a cooler surface, the water vapor can lose heat to it faster, and then it can change state from gas to a liquid. So B is definitely correct. When it's a hotter plate, then this no longer becomes a cooler surface, right? So this is definitely wrong. So anything in A is wrong. How about D? Changing the glass beaker, which is this one, to a metal cup of the same size. Now same size means exposed surface area is the same, so it's not affecting this. But if it's a metal cup, means it's a better conductor of heat. If it's a better conductor of heat, it can conduct heat from the flame faster into the water. Water can gain heat faster, evaporate faster, so more water vapor. So more water vapor will condense, and you have greater rate of condensation, more water collected. Therefore, D is also correct. So the answer here is number 4. Right, now we take a break before we go to section B. You may pause the video, take a break. Alright, welcome back. Now we will skip some questions because those are for P6. There are only 2 questions that we will need to look at for section B. First part is question 14. So in here, again you see, very common question. There's a stem, then they cut some parts. Now they cut food carrying tube. This means food can't go down past the part that's cut. So this part will swell, okay? And because it can't go past it, then more food will be stored in the fruits up here. So after some time, you compare the fruits of both plants. Fruits of plant with food carrying tubes removed, fruit of plant with stem cut. You notice this is smaller. Right, this one is bigger. So we then observe the plant with the food carrying tubes removed produce bigger fruits compared to the other plant. Why? Of course, you may pause to copy down the answer. There are 2 marks here, right? The first point, you must explain that you understand what's the big deal about cutting away the food carrying tubes. So if the food carrying tubes are removed, then food made in the leaves cannot be transported past the part that was cut, which is here. In other words, all the food made will be all staying up here. It won't go anywhere else. That's the first 1 mark. So where would the excess food go? The excess food will be stored in the fruits. It's like they keep pumping excess food in. It's like blowing the balloon bigger and bigger, which makes them grow bigger. This is your second 1 mark. Now we go to this question. Now, when Harry walked out from the air-conditioned room means the spectacles has become a cooler surface. Right, the spectacles fogged up with water droplets as shown below. So the spectacles will experience this when you leave an air-conditioned bus or leave an air-conditioned car, your spectacles become fogged. This fogging is actually a lot of tiny water droplets forming on it. How did it form? Because we're going to explain, right? The water vapor, important, in the air, outside the room, important also. Notice a different change in color. What happened to the water vapor in the air outside the room? It touched the cooler surface of his spectacles. So what happened if it touches the cooler surface of his spectacles? This water vapor in the air will lose heat and will condense into water droplets. This is a good answer that you should memorize to answer condensation question. source of the water vapor, touches a cooler surface, losing heat, change state, condense in the water droplets. Second part. Now, Harry tried wiping the water off, but it fogged up again soon after wiping. So your friend says, hey, just hold your spectacle lens in your palm is here, for 5 minutes. So if you hold in the palm for 5 minutes like this, okay, so what will happen to the spectacles? Well, the heat, so I'll suggest you use this answer. So the spectacles will gain heat from his hands. What happened when the spectacles gain heat? At first, the spectacles were in the air-conditioned room and it was a cooler surface. After gaining heat from his hand, it's not a cooler surface anymore. If it's not a cooler surface, then there will be no condensation happening on his spectacles. So this is the answer that I'd like you to learn. Now, one of my students gave a different answer that I thought was quite interesting. I thought about it. I think her answer is correct too. I will not share it here. But to that student who has a different answer, I did write down, learn a new answer. So please write this down as well. Why not I share it? So the other girl, right, her answer seemed to make sense. So what she wrote was, the heat from the spectacles gain heat from his hand. So what happens when the spectacles gain heat? All these water droplets will evaporate. That's why there wasn't any fogging. I think it's very hard to fault her for being wrong. I think it makes a lot of sense. So I accepted the answer. But I think the intent of the person designing this question is actually this. So let's learn this. Now, I noticed there's a last page here, which I didn't quite see until now. Okay, so let's go through this. Every car has these buttons that provide heat to the car windscreen. This is the back of the car. These are actually wires. So what happens when there are these wires? When you switch it on, wires here will become hot. Okay. Now, why am I not going through this at first? Because it's on something about electrical system, but never mind, we can still do this. This wire become hot. And become hot is like this, right? It's like putting your spectacle lens on your palm to make the spectacle lens gain heat, so it will not have condensation. Remember, if it's not a cooler surface, there will be no condensation. Not cooler surface, no condensation. So by switching on a button that makes this piece of glass, the windscreen here, hot, then it will not be a cooler surface, then there will be no condensation. So if it becomes too cold, what happens on the windscreen? What will form? We talk about it, right? Water droplets will form. 1 mark for this. Next one, explain how pressing the buttons help the driver to see clearly through the windscreen when the windscreen becomes too cold. So let's step by step, right? So when the buttons are pressed, the wires become hot and the windscreen gains heat and stop being a cooler surface. So there will not be any condensation on it. And if there's no condensation, the driver can see through clearly. Now, of course, it looks like it's very long, but because I'm writing like just 5 to 6 words per sentence, if you're filling a whole sentence, you can fill in the answer here. Alright, that comes to the end of this lesson for this worksheet. So those in my class this year, or those in my class were asked to watch this, whether in 2022 or not, please make sure you do the corrections. I'll collect it to check. Everyone, thank you for watching. Have a nice day. I'll see you in the next video.